Welcome to the exam preparation session for DP-700, Implementing Data Engineering Solutions using Microsoft Fabric. This session will guide you through the essential strategies for taking the DP-700 exam, and the focus is on exam strategy and preparation, as well as a quick technology review, but we're not going to be teaching all of those underlying concepts. We'll cover the objectives, best practices, tips and tricks, and exam key points, and the video will include a lot of visual information for reference. My name is Locky, I'm a Microsoft technical trainer, and I've been with Microsoft since 2018, helping high compliance clients all around the world. You can find me on LinkedIn if you'd like to follow along. This slide is going to show the certification journey to become a Microsoft Certified Fabric Data Engineer Associate. This exam is designed for people with hands-on experience in designing, implementing, and managing data solutions using Microsoft Fabric. And there's 4 steps highlighted: some optional training, including the instructor-led DP-700 course, and optionally the DP-600 Fabric Analytics Engineer Associate as a related credential, the exam prep series, this session. Then you need to schedule and set the exam, and the credential is yours. There's lots of self-study resources too. Don't forget important ones such as the AI Skills Navigator and Microsoft Learn to be able to go through and learn all of the underlying pieces in further depth. Remember, we're not focusing on teaching the underlying technologies, we're focusing on what is tested, how it's tested, and where to spend your study time. This slide shows the weighting of the skills measured on the exam. DP-700 has 3 objective domains, each weighted in roughly that 30 to 35% range, so there is no single domain that dominates, so allocate your study time evenly. Episode 1 is implementing and managing an analytics solution. 2 is going to be focused on the ingest and transformation of data, and the 3rd is monitoring, optimizing, and the analytics solutions. Each group has that weighting indicating that they are the same, so we're going to make sure that you're familiar with all of them in equal terms. Keep in mind that the weighting does shift slightly and the exact mix of questions is different for every exam taker. So don't bank on one domain being a little bit higher than the other. Keep your study equal across the board. Now, the objectives of this session: by the time you are done, you'll be able to, remember how to ingest and transform your data, secure and manage an analytics solution, and monitor and optimize said analytics solution. It's not a replacement for that training or any of your own hands-on experience. This is just to guide you what to expect in that exam, and you need to have the details already in head. Use this to spot the knowledge gaps and focus your time to make sure that you know exactly where you need to put your focus next. All right, let's start on our first objective here. We are going to look at implement and manage an analytics solution. There are 3 specific skills that we are measuring within this: configure Microsoft Fabric workspace settings, implement and lifecycle management within Fabric, and configure security and governance. Don't forget to also think about the orchestration of processes within. This slide lists the full set of skills that you may be tested on for Objective 1. These may include items, meaning they may or may not appear in your exam, and the list is not exhaustive. But we're not going to need to cover everything in detail today. Just make sure you can remember the pieces you see here in some way before sitting that exam. Full detailed overviews and to see the full list in your own time, head on over to the official study guide. Workspace settings in Microsoft Fabric help teams organize, secure, and optimize their data workflows. Each workspace type, Spark, Data, Domain, and OneLake, has unique configuration requirements that support different functionalities within the Fabric environment. Fabric administrators manage workspaces from the admin portal, and available options vary based on workspace type and status. Use the tab in the admin portal to view all the tenant workspaces. The first is Spark. The components in there include things like Spark Compute, libraries, and shared resources. You need to make sure that you're putting in the right libraries for effective publishing so people can use the workspace properly. Within the OneLake workspace settings, we're going to focus more on just standard sort of options within the OneLake. The available options are still going to vary based on the different workspace types. Domain workspace settings are focused on tenant-level governance settings that can be delegated to the domain level. This means business units or departments can define their own rules, restrictions, and policies. And data workflow workspace settings require a Fabric tenant with an active subscription and a Fabric-enabled workspace. But once there, it allows you to configure data flows and pipelines for ETL and ELT. Make sure you think in the exam about these categories. Those 4 categories are distinct, and the exam loves to test whether you're going to route a scenario to one particular one. So if a question mentions Spark, you can presume a Spark workspace setting. If it mentions governance or business units, we can consider its domain. Make sure you know the unique properties of each of these workspaces so you can easily identify which one is going to be the right one for the question at hand. Now, next up, we need to talk about version control. Fabric supports full integration with a whole bunch of popular Git platforms like Azure DevOps, GitHub Cloud, etc. And that version control will help teams collaborate efficiently, track workspace changes, and make code integrity across different development stations easy. There are a few prerequisites, though, to make this work. You'll require some Fabric capacity, premium or trial, tenant switches enabled for creating and syncing Fabric items with external locations, and of course, access to a Git repo in your environment. There are a number of steps that you do need to configure as per the slide that you see, though. Creating the workspace, loading in content, connecting that workspace to your repository, putting in branch and enabling that synchronization, and then of course, you need to start managing your branches, thinking about development strategies around feature, dev, or main, and then resolve conflicts as per a normal Git environment. There's a number of different source control operations that you need to be thinking about as part of this. Remember, commit is to push workspace changes to the branch, update brings them down, undo reverses a change you've made, and disconnect disconnects Git from the workspace. You'll also require some relatively high-level permissions to be able to make these changes. Workspace admins are primarily the people doing the work to connect and disconnect workspaces, whereas members are going to be more focused on the actual change commits. Premium or trial capacity is that gating prerequisite, though. So if you see a scenario talking about Git, make sure that there's no mention of the particular capacity that they already have permissioned. And of course, those permissions are critical too. Least privilege should always be the model we follow, so make sure you're considering what is the minimum required for the person to be able to get their job done, especially when we're talking about the connection and disconnection of workspaces as a potential implication. Next up, database projects. Continuing through the hit list, we need to go into how these work, and there is a development process that we will be following here. Extract, edit, build, commit, and update. These 5 stages that we follow enable project-based SQL development in your Fabric environment and is essentially the practice that we use to follow when we need to extract that schema from a database. By doing the extraction, editing the SQL objects, building the project, committing changes to the source control, and then updating that schema updating the database with the new schema, we're able to build out that easy pipeline to be able to do the work we need. There's a number of tools we need to remember, though. SQL package for those DAC files, incremental updates to make sure that you're only applying the particular changes you need, and of course, don't forget about the cross-platform component of this as well. If you see something talking about Fabric SQL database, SQL packages, these sorts of components, these are trigger phases to watch for, and especially deploy from source control. In combination with SQL, this tells you that we are going to be needing a database project to do the work we need. Now, in conjunction with our projects there, we are also going to need to look at pipelines. Fabric pipelines are designed to move data between different environments or within the same environment, allowing you to develop and test content before it actually reaches an end user. Make sure you're setting your pipeline structure by defining all of the required stages. By default, there are 3 stages: development, test, and production, and 2 different creation methods, either through the workspace icon in the left navigation pane, or you can use the create deployment pipeline icon at the top of the workspace. Once you've done this, stage your configuration changes and assign the permissions per stage to control who can deploy into and out of that stage. If a scenario is just talking about the word promoting, we typically use a pipeline as our promotion mechanism for data moving through these stages. Think of them as a change control wrapper around your Git integration. Whereas Git is tracking the code, the deployment pipelines are moving the relevant items between environments under those controlled permissions when required. Next up, our access controls. I've already talked about least privilege, and we need to remember that this applies in many spots. Fabric uses a flexible permission model to manage and access data to workspaces and the workspaces within themselves. So make sure your workspace roles are consistent with the actions someone actually needs to take. Viewers are read-only. Contributors are essentially able to do everything except for adding new members into an environment. Members have the ability to add members, and admins have the ability to both add other admins and delete the workspace. It is a ladder up. The higher in role will inherit everything below it, so make sure that for your consumers and your builders, you match the role to the least privilege required. If they're talking about the ability to add a user, least privilege would be member, not admin. If they're talking about deleting a workspace, well, that is an admin role, and we don't have too much of a choice. Always pick the lowest option based on the requirements available. We also have the ability to work through with access controls at the item level space. Since item permissions control access to those individual pieces within a workspace, we can be used to give access to a user for just a specific piece of data that's relevant to their role and not the entire workspace space. It is a separate structure though, and there are a few different things you'll need to consider. The main one being the different Fabric items like semantic model, warehouse, SQL database, data factory, lakehouse, data science, real-time intelligence. These all have slightly different mechanisms for what you can assign permissions to at an item level. To share an item in this manner though, select the item, hit manage permissions, and then you can use that to be able to assign item permissions directly. This is really a narrow access scenario. So if you're seeing scenarios talking about sharing something with a single analyst, this would be the mechanism that we would look to because, again, it is a better implementation of least privilege than giving them access to the entire workspace. This is not the only type of access control we have as well. If you're working with something that is in a database form, that SQL analytics component, you can use row-level security as well. Row-level security allows us to define some sort of key that we can identify within a warehouse or a SQL Analytics endpoint or a lakehouse. And then, based on different rights, we can see, well, should someone be able to see that particular piece of data? To set this up, you'll need to connect to the warehouse or analytics endpoint, then define the policies that you want, essentially creating roles that predicate which particular rows we want hidden or shown, then test it against a username that's assigned that to see the filtered results. Make sure you're monitoring and maintaining this. This isn't a one or done. The goal for this is to achieve things like, if I'm in region A, I should only be able to see region A data. If I'm in region B data should be visible to me. Compliance, control, where there is some specific key that means only certain users from certain areas in the business or the globe should be able to see information. Of course, if you don't want to go sideways, you can go top down as well. We can implement column level security too using the grantee SQL statement. For simplicity of management, assigning permissions to roles is always preferred to assigning to individuals when we use any of these options, but especially with something like column level security. If we need to make sure that we are, hiding a customer ID or a credit card number from certain types of users, it is always best practice to ensure that we use those roles simply because it makes access control significantly easier to work out down the line. If you ever see, how do I hide a social security number or hide a salary figure from a specific person, that is a CLS via grant, not row-level security problem. If you imagine that Charlie at Contoso is a marketing analyst who needs access to the customer table but must never see the credit card or social security number of that customer, a grant select against a role that Charlie holds is the best way to ensure that we have a narrow projection against that table whilst not affecting the raw data underlying it. Now I'm down into the last few pieces of access control to cover, and the next one is object level security. If you're thinking about file or folder level access, this is sort of what we're looking for here. It allows us to create roles on Power BI desktop semantic models and use external tools such as the tabular editor to be able to essentially control what people can see in that way. This is truly the same as giving access to a folder or file, but within the OneLake context. So if we have a specific table or column that we need to hide, this allows you to hide the entire table from a user as opposed to hiding specific components. Within a semantic model, you can actually use OLS to be able to hide specific columns as well as an alternative to common column level security that we see within the SQL space. One last interesting point though is dynamic data masking, which is available in a number of different database-focused formats. Instead of hiding a column, we could instead obfuscate it using a function. This can be configured on designated database fields to hide certain types of sensitive data in the query result sets without altering the actual data. Think like showing the last 4 digits of a credit card number so an agent over the phone can verify someone is who they say they are, or masking most of an email address, or even the whole thing, even replacing a string with a random set of numbers that still at least fits the pattern so we can identify what roughly should be there. You can, of course, create full custom strings using prefixes, paddings, and suffixes as well. DDM has some very interesting use cases, but it essentially allows us to have a user with lower privilege at least understand what should be there. Make sure you're using concrete examples to anchor the mask types as well. So an email mask showing just the first letter, J, a series of asterisks at contoso.com, would be a better example than hiding the whole field, because if we're doing it at that point, we may as well just go through and use column level security to prevent access, full stop. Okay, now within all of these government frameworks, we still have a sensitivity system that we can utilize. The same sensitivity labeling system that we use on emails, Teams messages, and within our Purview stack also applies to our Fabric space. You can apply sensitivity labels in a couple of different ways. There's a flyout menu on the item header, and in the item settings, you can endorse Fabric items via promotions, certifications, and master data designations. Essentially, promotions are author-driven, certifications are admin-driven, and for highly trusted content, and master data designates authoritative reference data. These allow you to reference these points whilst also simultaneously applying that sensitivity component to it. So in real time, we can understand how people are accessing different pieces of data in different scenarios. Don't forget there is some important other pieces that we can utilize as part of this. We can mirror logs to a central store to be able to track this. Within each of the models, there is a mechanism to be able to understand how people are using this. And this allows us to not only set a level of trustworthiness, but also sensitivity in combination to allow people to see the both. If you think of sensitivity labels like a classification stamp on a document, public, internal, confidential, highly confidential, they'll travel with the item. But endorsement is the team's signal to say this is a piece of data that is worth using that you can trust. Okay, last few pieces we need to touch on. OneLake. It is the OneDrive for your entire business, and it is designed to work across lakehouse, warehouse, and semantic models with permissions inheriting from the parent item or workspace. This can present a very interesting way for us to work because we can start to assign sub-roles to very specific purposes within the OneLake directly. It does require opt-in, and it does require the creation of new roles and where you need to select what data, tables, or folders are part of it. The last part is you can assign directly to users, but the best practice is always to assign to a group instead of an individual. It's just significantly easier to manage at scale. This is where we can do really fine-grained data lake level access on top of your workspace and item permissions. There's a default reader role that must be removed to be able to change it from a position of everyone in the workspace can read to only those who have these new roles can read. But once you do that, this gives you an easy way to gate access to the data layer on top of the other types of workspace settings and controls we've already seen. Okay, let's move away from what we've touched on here. I've got just the last few features that I want to touch on in integration. To choose the right data integration service in Microsoft Fabric, we go through 4 guiding questions. Each one helps you narrow the answer based on intent, skill, workload, and complexity. The first is, what's your primary goal? Do you want to ingest, transform, replicate, orchestrate? What is the thing you need to do? Next is your skill level, and more your technical skill level. Do you like no code or low code, or are you more comfortable working directly with code? What type of data workload are you working with? Batching, bulking, incremental changes, continuous streaming, near real time, these all have different considerations, especially if you're also thinking about data transformation. Is it light or is it complex? Pipelines are suiting orchestration in low-code data movement and parameterized activities, where the notebooks focus on PySpark, SQL, or Scala. These different options are really truly focused on either a low-code orchestration focus or a high-code, deep machine learning style approach. When you see an exam scenario that mixes both or presents them, think about the user. Essentially, a pipeline is kind of like a conductor. Your notebook's more like an instrument. It's executed to be able to do those complex tasks when we need it. Now, of course, if we are going to be working with event-driven components, pipelines can occur directly when an event happens. Very useful for us to have them, but they also have more traditional mechanisms. On demand, you can manually or ad hoc run something for debugging purposes. You can also run just on a normal schedule, so once a day, or use a tumbling window for periodic jobs that come through. Essentially, based on the particular requirements you need, you can stretch and use these in different ways. Now, to set up something like a storage event trigger, one of the more common types that we see, choose your canvas, open the trigger, choose that data activator, and then select if it is a OneLake or Azure Blob setup. Once you have that in place, we need to connect the event stream to the workspace and then choose how we want to actually react. Reflex triggers are what we use to do this, so we'll create one of those. Once the trigger is active, it will fire when new things are uploaded. This is a really common approach that we use, and it allows us to ingest, transform, and publish in different orders. There is, of course, different orchestration patterns outside of that, such as parallelizing using fan in, fan out, using various types of if this, then that style conditional branching. And of course, we've got a lot of different retry and compensation options to be able to work with systems that need to be backed off if they get hit a little too hard. If you do need to use a notebook to do a transformation as well, you can actually still do it for this. Create a pipeline first. The pipeline will act as that orchestrator to kick off the notebook. Always think of it as the conductor and the instrument. When we use these different components, also remember, parameterize things wherever possible. If we can make a pipeline more reusable, generic, something that we can pick up and use again, that is always a better option. Parameterize and template your pipelines and prefer things like tumbling windows to allow aligned ingestion of data, little extra capture points either side to make sure that when we use the data, we are actually meeting and capturing everything we need. All right, let's go through our last little recap here. We covered 3 main areas: configuring the Fabric workspace settings across Spark, OneLake, domain, and data workflows. We implemented lifecycle management. I showed you about Git, database projects, a few different things on deployment pipelines. We looked at a lot of different options for security and governance, including things of workspace settings as well as sensitivity labels. And we talked a little bit about orchestration, how to choose between a pipeline versus a notebook, different types of schedules, event-based triggers, etc. Remember, each of the objectives are going to account for roughly the same 30 to 35% of the exam. So focus on the easy spots to get you started if you need to focus on this spot. Workspace settings, lifecycle, security roles, orchestration. These are all common questions that we'll find within the first section. Now on to Objective 2, ingest and transform data. This is where the data engineering work really lives, so let's make it work for us. The skills measured here are going to be design and implement loading patterns, ingest and transform batch data, and ingest and transform streaming data. This slide lists the full set of skills you may be tested on for Objective 2. Now remember, these are those may includes. They may or may not appear in your exam specifically. Just make sure that you are familiar with all of the pieces that you see here a little bit before you head in. For more detailed overviews and to see the full list in your own time, you can head on over to the official study guide. Now we need to start somewhere in this particular objective, so let us start with our data loads. There are a number of different ways that we can load data into an environment. So let's just make sure we've got the supporting concepts in play. The first is a full data load. It's kind of there in the name. We load the full amount of data at once and transfer an entire data set in. For migration or a complete refresh of data, these are perfect, and they're essentially more or less just a direct copy. But of course, we do also have incremental options here. Now, incrementals are interesting because they are more, how do I want to say, efficient in many ways, but we need to make sure that we have a marker, a watermark, or something that allows us to work out how we are not going to repeat or duplicate components of the data that are there. It takes a little bit more to set up, but for many data stores, this is a better option broadly. And we want to model that data. There are a few different options that we have here, but a star schema is one of the best ways to deal with lots of different facts together. A single central fact table with multiple surrounding components that are related. Lastly, when we're thinking about streaming data, the ones you need to think of are going to be Azure Blob, OneLake, event hubs. These are all the key things that we typically use for stateful places where we need to deal with different types of loading patterns when we're dealing with data coming in constantly. Incremental data, just remember, it needs some sort of state system. And events-based data, the streaming components, that is going to require something that supports that streaming mechanism to get it in. Now, in terms of where to store your data, it's really driven by the primary user and what you're bringing to the table. I've got a quick comparison here that takes you through a lot of the different options. Event House, Cosmos DB in Fabric, SQL Database in Fabric, Fabric Data Warehouse, and Lakehouse. Just make sure you try and match your data to the persona that needs to use it. So app devs, the people using KQL, SQL, or no-code, use Event House. High-velocity streaming, very good for time series data. AI and app developers who are more familiar with NoSQL and the things that we find within PostgreSQL, look to Cosmos DB in Fabric. That's going to be the best place for them. AI app developers who are more focused on the T-SQL side of the fence, well, that's going to be your SQL database in Fabric. Data warehouse developers, your architects, your database developers using that star schema, or more familiar with SQL, again, look to the data warehouse. And everyone else who wants the code, look to PySpark, look to the Lakehouse. When the question gives you that persona, SQL developer, data scientist, real-time analyst, think about where that match goes. It's the easiest way to identify where the data actually needs to end up. A technology stack is useful, but a persona stack, if you get it right, the data store basically picks itself. Now, when you are using these different data stores, we also need to think about some of the different options we have for handling that data for transformation. We covered a few in Objective 1, but these are transformation tools based on specific skill sets. The first is going to be our Dataflow Gen 2. Dataflow Gen 2 is designed for code-free data prep and is an extremely good option, but notebooks have the same space focused on code. So it really depends on what this particular skill set of people are. Continue with Dataflow though. 170 built-in connectors, custom SDK, and the ability to work across a large range of different data integration spaces. If you want ETL, you have a SQL skill set, or you just prefer low or no code, that is the way that we would go. Since notebooks have that code-focused approach, if you see the words Spark, Scalar, Python, SQL, R, these are the sorts of things that we need to make notebooks work well. An event stream basically takes the people who are interested in notebooks but prefer to work in KQL and T-SQL. These are SQL-based stream analytics and our flagship for that streaming data. Since they can support JSON, CSVs, TXT files, as well as all of those common sort of QL-style languages, it's an easy way to do medium-style transformations. Try and match the data store and the experience of the persona presented to each of these. For notebooks, it's complex-driven tasks by code. For KQL, it's stream analytics, real-time. T-SQL's focused on things like ETL using a SQL environment. If you could justify your choice to someone, you know you've made the right call with it. Just remember, if it is emphasizing low code, of the options that we see here, 100% Dataflow will be the way to go. It is the one that is focused on a almost code-free environment. One of the important things to think about with your data is sometimes you don't actually want to hold your data. Shortcuts. Shortcuts are a way for us to essentially symbolically link across to an external data store. It means that it doesn't have to be in the Fabric environment for us to use it in Fabric. Now, these can reduce storage costs by preventing replication and keep data consistent across multiple different spots. It essentially gives you a single copy promise ability. But the thing to remember, even if you create them programmatically, even if you're monitoring them closely, is that if a shortcut breaks, the shortcut breaks. You need to be liaising with those who own the data on the other side of the fence, making sure that you understand who controls the components. So, whilst you can manage it here, it is a shortcut. If the shortcut gets broken, we need to re-establish it there. So, what you need to think about. Number one, shortcuts are exactly that, so make sure you are liaising with those who own the data on the other side. Number two, the security model. How are you going to authenticate to an external store? We need to think about how that works and what we use. And number three, use them in the right moment. Avoiding data duplication, having a true one source of truth where we can't move it or don't want to move it from elsewhere, or where we want to pull things in if we need to bring things in totally. Okay. Now, as a complete alternative to what we see here, we could also just mirror. There are very valid reasons why we would want to mirror data, and I'm going to use databases as the primary way to talk about this. In many scenarios, this is the real thing that we do tend to mirror. Database mirroring is a full replication of an operational database into OneLake. Now, we do also have lighter options such as metadata mirroring to just replicate only the schema, or open mirroring to focus on specific database components to mirror across. But the point of this is that we are able to move data into the OneLake, and then we avoid the pitfalls of shortcuts entirely. It is a double up of the data, but now you can do as much real-time querying and ETL and anything you want against that DB without having to worry about how it will affect the source. Remember, if you're thinking about a question where it says, bring my DB into Fabrics, mirror it. It's the easiest way to make it happen in a seamless, low latency mechanism. It's also a great way to give protection. You can think about this almost like a redundancy source, while still giving you the optimization, a place to run all of the things you need to without affecting that main source of data from a performance perspective. Now, I'm an automation person. That is my main thing, and pipelines are the main thing I tend to leverage myself. So I'm quite excited to talk about them quickly here. These allow us to think of ETL tasks, taking data from A to B and moving it wherever it needs to go in clear, concise, repeatable manners. There is a 4-step flow that we use for creating a pipeline. Getting a data source, connecting the source, choosing where it goes, and going. Pipelines are kind of straightforward. They allow for very light transformation as well, so if we need to take something from one file format to another with minimal transformation, or if we need to do simple error checking, we can essentially build that in. It's an orchestrator. Low code, easy to put together, and is great for things like copy activities, doing conditional exceptions, lookups, moving things through. And because it can be parameterized as well, we can reuse them for multiple purposes. I've seen them used to transfer logs, to transfer things between environments. You can use them for a whole range of different components using entirely a visual canvas. Extremely versatile if that's what you're looking for. Now, of course, transformation is also possible within the pipeline space. So if you are wanting to create one of these pipeline setups, we'll first need to make a data flow. This does all of the same setup that we had before, but before we send the data somewhere else, we add those transformation steps. These are low-code ways to clean and transform data. Very, very useful if all we need to do is just strip out irrelevant components or move things to a slightly different format or kind of get something that's in a file and move it into a database or whatever we need there. Low-code transformations like this are critical to ensure that everything works in the way that it should. It's the automation principle of it's not always about handling every exception at the time that you ingest. It's about building out a pathway where every piece of data looks the right way when it hits its destination. When you're working with your pipelines, know that they are fully auditable and monitorable so you can ensure data consistency across the entire way and get yourself a visual reviewable mechanism to understand what changes were made. Now, if pipelines are not quite doing what you need, there are plenty of other transformation options for you. These are the ways that we can transform using something like PySpark, SQL, or KQL. If you are more familiar with one of these options, use that for transformation instead. You'll need to create a notebook to be able to do this work, but once you do this, you just need to go through and decide what's in place. I've got an example on the slide here talking about city-based dimensions, and we're using that as a kind of example to show you the step-by-step of uploading, creating your delta, and then you can query the data, and the querying is where we also perform our modifications. Think about the different types of transformations that you could do in this context. Since it's a native Spark or T-SQL experience, it essentially gets you the ability to choose the tool of your choice. Remember, this is another one of those ones where persona is going to matter. If we see people talking about PySpark, SQL, KQL, those sorts of critical components there, we are looking at something that is available in the notebook or a warehouse because that is the primary place that we use. Remember that some of these endpoints are also only going to be read-only as a focus, but notebooks allow us to do writing if we need to as well. Last few pieces here in the transformation space. This is a number of different batch operations that we can use. I want you to think about this for mechanisms where you have data coming in and we need to do some sort of true up. Denormalizing is taking a product table for a category and flattening it down to simple context for quick query performance. Aggregation is taking multiple different data sources and combining them together. It also involves pre-calculation, totals, averages, that sort of stuff. We can use these different types of flows and patterns to be able to just essentially pre-prepare. When we work in a kitchen, we don't necessarily work with raw ingredients from scratch. What we often have is the sous chef. They are there preparing and making sure that each piece of the ingredients are ready to go so the chef can cook straight away. Think about things like your star schema, the ability to have the single fact with the surrounding components. By pre-preparing all of these pieces so they are in the form that we need for analytics, you can greatly increase your performance, speed, and make sure that operations that we need are going to run faster. If there is a simple operation you can run to improve your query speed, try and plan it into your ETL process and think about what periodic updates are going to look like. What's the latency look like? How can we make sure that we still are able to work within, say, a streaming or batch context where we do this sort of transformation? It's essentially trading a little bit of storage for better performance. You need to make that call. It may be a cost implication, it may be something else, but there is going to be a mechanism we can use. If you want a really simple practical matter, replace nulls with zero. It is one of the easiest operations you can perform in this sort of denormalization setup, and it can drastically reduce errors downstream for things that aren't able to handle null directly. Now we need to choose the right way to stream our data into the Fabric workspace. Now, there's a couple of common streaming sources you need to know related to the Microsoft environment. Azure Event Hubs is something we use for telemetry and streaming data in custom ways. It's just an event stream for the purposes of Fabric, though. IoT Hub, for our purposes, is an event stream, but for the IoT people, it is incredible. It allows you to push and pull data directly from cameras, manufacturing line sensors, and be able to work and manage a whole range of different devices there. But for our purposes, is an easy way to be able to just have an event stream of all of that information coming through. And of course, we've got a number of built-in synthetic streams as well in the form of sample data. If you just need a test bed, look to those. The last big one, though, is that if you are using a third-party application that supports Kafka, you can just use that. We fully support Kafka streams directly via Event Stream, and it allows us to pick and choose based on what you need. Now, the exam loves team skills cues. We see these sorts of questions pop up frequently because it's a translation of persona through to technology. So analysts will want low code, they'll look into event streams. We're thinking structured streaming, that'll be the Spark devs. If we're looking at operational telemetry, it'll be KQL. Think about how you would match that technology to each one of these options here. Which one would you pick based on the personas that you see? Okay. Now, if you were using different types of data stores, we've got different options when we have that real-time data coming through. Natively, we support the Event House that has that KQ option and the ability to query the data with a number of different tiers depending on how fast or how long you need to keep your information. Essentially, you can choose hot or cold paths depending on what sort of way the data is being used. If you're dealing with true real-time or anything high velocity, use the Event House. It is just native storage and it keeps it simple. Automatic replication, easy to work with, that sort of stuff. Now, mirrored storage, we covered that for databases, but it is a great option if you just need an easy solution to bring it in. It's free to set up because there's a storage cost associated, so we're not going to charge you twice. We just want to make sure that it's in there as an easy read-only destination you can use for transformation. And, of course, shortcuts. If you've got a fast data store and we don't want to pull it in, let's say you're hosting data in Azure directly in a data lake there, or you're pulling out to an external source hosted in another provider, we don't have to migrate or duplicate that in if it doesn't make sense. Focus on when to think about the different options here. We have accelerated and non-accelerated versions of the shortcuts series. What does that look like in terms of cached versus non-cached scenarios? Does that change how you think about the use of a shortcut as well? If we are using repeated queries, make sure you're thinking about latency as well. Shortcuts will be as long as it takes to get from where you are located in Azure out to your other location. So think about that fabric to location distance. It's where sometimes it just makes more sense to use the native storage or to mirror to get that better speed. Now, a lot of these things are coming through via an event stream. This is just the 4-step authoring flow to actually create one. Selecting fields and a little bit of visual transformation is part of it. You can see it is a GUI-based approach though. No code required directly. You can connect your various sources together, choose each step of the process that we need to work through, and create a process workflow. You'll enter your edit mode and then insert whatever transformation operations you need. Aggregation, expanding, filtering, group by. We've already talked about the different types of data we can feed in as well. So think about what you'd get if you had Lakehouse, Event House, Activator components all pulling in. And importantly for me, when I use this, the editor lets me preview whether it's going to do the thing I'm expecting at the end with some sample data. I don't have to wait for the whole thing to complete to know that it's at least going to do what I'm expecting. There is a whole bunch of different transformations we can do here. Filtering, aggregation, joins, routing. Make sure you consider the use of these because it is also a visual, auditable component. We can see exactly how the pipeline's working and you can see exactly how the transformation worked. There is also a couple of limitations to be aware of, and it's primarily message size and retention period. If you're thinking about a very high compliance scenario, like a lot of my customers, sometimes we might need to think about separate audit logs or exporting them elsewhere or thinking about just different ways in which we need to store that sort of information for our purposes. It's all just based on the scenario. Now, of course, if you are more focused on high code rather than low code, Spark's there for you right away. You can use Python script to append a Delta table named streaming table directly in Apache Spark. So choose your workspace, create a lakehouse, create a Spark job definition, and then work your way through. There's some retry policies, some different run components that you'll need to set up, and after the script runs, the table will be there. It'll have timestamps and value columns that are created in the lakehouse, and now we can view the data using really whatever mechanism we want. SQL Analytics endpoint via the table streaming data is the easiest way that I can think. The script is going to read continuously, so every new row that gets added in will get put across into the Delta table. You'll save it as a PY file, upload it to Fabric, and then it will use that as a way to continue going. Once running, the job will just keep appending that new data and you can query it live from the analytics endpoint directly. So if it's continuous streaming but code first, you know where to go. Across to here, set up a Delta table and use the Spark streaming service. There is that retry policy as well. Don't think of it because it's likely going to be a where do I configure the retry policy style question, which sometimes comes up. Now, I've mentioned KQL a number of times, but the Kusto query language is one of the best ways to deal with extremely large data stores. We use this all over the Microsoft ecosystem. In Azure, we use it for our log components. Within our security space, we use it for Sentinel. We use it for the graph. We use it for pretty much every type of query across the space. So you will find people will often be quite familiar with KQL. If you're looking ways to explore, query, and manage your data through that sort of setup, it gives you an easy, familiar way to work with that language, whilst also ensuring that you have the ability to navigate across different connections, merge together, and do live querying across large data stores. KQL has a number of really interesting benefits, including its ability to live mesh different stores together. So think about the detailed database properties that you're using, how you'd integrate it across, and of course, don't forget things like retention policies that can still come into play. It's the right place where you are dealing with high throughput telemetry, anything with a time-based series, anything with real-time components. These are all things that KQL just shine at. So if you're thinking of integrating across to anything else in the various Microsoft ecosystem space, even something like Azure Data Explorer, this is the syntax we'll need, and it just means you've got something you can use and it'll pay off way outside of Fabric. All right, let's continue through. I've got a few last cleanup things I need to cover. Next, we need to talk about windowing. Stream analytics jobs of whatever type support different windowing functions. It's essentially overlap. How do you want your data to be ingested? Tumbling window is the best default because it's fixed size, it gets segments, and it's easy to be able to pop through. But a hopping window can be good if we're concerned about results being omitted. Sliding windows will adjust based on different size contexts that come through, so as an event enters and leaves, it's great for a dynamic pattern where you're not sure how fast the data is going to be coming through. We do also support sessions and snapshots too. Sessions are focused on events with the same timestamp, and snapshots are more focused on moments that happen at the same time. Now, between these, you can think of these almost like a group by, so make sure you're just grouping in the right way. Don't confuse things like hopping with sliding. Hopping have that fixed slide and fixed interval. They're predictable, but sliding windows are event-driven, so they only produce outputs when something enters or leaves. If you see something mentioning every 1 minute, that's going to be a hopping over a sliding. With that, we have reached the end of our second objective. In the objective, we covered a bunch of things. Designing and implementing loading patterns, looking at incremental versus full, watermarking, dimensional modes, streaming loading data patterns, a whole bunch of things like that. We also looked at the ingesting and transforming of batch data. I talked about data stores, transformation tools, shortcuts, mirroring, ingesting via pipelines, transforming using PySpark, SQL, KQL, handling denormalization. And the third thing was ingesting and transforming streaming data. You got to choose the right engine, choosing the different options that are there, make sure you pick the right thing, and then talking about how to do that transformation effectively. Remember, this section covers that same 30 to 35% of the exam as the other objectives, so don't slouch on it. Now on to objective 3, monitor and optimize an analytic solution. The skills measured here are monitoring Fabric items, identifying and resolving errors, and optimizing performance. In Fabric, monitoring isn't about watching a data flow directly. It's usually about using the right tool to find where optimizations are possible, troubleshoot issues, and keep your data warehouse and analytics pipelines on track. We need to know how to use all of these various metrics that are available to track compute usage, cost, and make sure that query insights are giving us the view that we require to understand that everything's working correctly. There are a lot of different things that potentially could be covered within this section. Make sure you're checking out the official study guide over on the AI Skills Navigator. This will give you great details, including a lot of the may includes. Feel free to pause and take a look to see all of the details, or again, head on over to the study guide. Microsoft Fabric Monitoring Hub enables us to be able to look through various Fabric activities from one central location. The hub displays activities for a whole bunch of different Fabric items: pipelines, data flows, data marts, lakehouses, notebooks, semantic models, and Spark job definitions. Think of this as your single pane of glass for any sort of activity across the data engineering items. If a scenario is asking, where can I see last night's pipeline, or if a data flow refresh worked, the answer is always going to be that monitoring hub. Now, because we have one central monitoring solution, we also have one easy alerting system. You can use targeted alerts in Fabric to proactively detect and respond to ingestion, transformation, semantic model refreshes, and system issues, so teams can start remediating problems before they actually impact business operations. I've got 3 main categories that I've grouped here. The first is activator alerts. Think real-time. A KQL query or a real-time dashboard alert, a Fabric alert, these are the things that happen real-time there. A pipeline or data integration alert, something that's happening in a programmatic fashion that may need attention, or a system monitoring alert. Performance thresholds that you set, capacity utilization, data quality, these sorts of alerts there. Think about signal sources when you're matching the alert types. Knowing these categories can easily help you ID what sort of alert we're dealing with and what sort of response is going to be appropriate based on the type of alert. Now, next let's talk about pipelines specifically. There are a number of different potential errors that can happen in a pipeline related to conditional logic. So we typically ask that you create error handling. Now, if you do this, it allows you to really think about, does this need to be an alert, or is there a way that I can actually deal with that error in the pipeline itself? A fault-tolerant workflow is always better than one that alerts loudly. We need to make sure that common events that happen that may induce errors can be caught using something like a try-catch, or that can be skipped using a do-if-else sort of setup. The exam may ask you to match these various patterns to some scenarios, so really try and map this in your head. You want to recognize some of the conditional logic too, ands or ors, and the different dependencies that can introduce. What happens when we have shared or cascading errors, and how to build those resilient pipelines. If you want a fallback path on failure, the easiest thing is a try-catch pattern. Do-if-else is also a good option if you happen to know all of the potential options that you may face. They're not interchangeable, but matching the right conditional logic to the scenario is pretty straightforward once we understand the components. Now, data flows require a slightly different type of troubleshooting. These pipeline issues in Fabric are usually focused on things like connection problems, authentication issues, refresh errors, that sort of stuff. There's three common error categories that we may run into. The configuration error at the gateway. At this moment, we really need to go and check the gateway status. You can run a PowerShell command to do exactly that, focus on the resource group, and then just query it directly. For an authentication failure message, you want to verify that the tokens are still correct. Get AZ access token is the query that we use there against the particular API that you need to use. And for user permission errors, we've got an example here that you can use to check against a database. So check against the permissions base to see if the principal ID has it there. There's a lot of common issues that you can find. Outdated or missing on-premises data gateway authentication, auth token failures, expired credentials. These are things that we just run into sometimes. So try and think about those common points. Refresh errors can also be presented in very odd ways. So if you ever see something that says the database is empty, consider, is the database empty? It might simply be that a connection is not working, a network port has been blocked, or something along those ways. Try and match the symptom to the layer. Once you can do that, it will help you easily identify where the error actually is and get to the root cause fast. Now, once we do have errors in place in something like a notebook, we also need to think about how we're going to categorize those errors. There is a lot of potential error messages you can get, but the categories and resolutions are fairly straightforward. A lot of the time it involves restarting a session, adjusting timeout settings, or looking at things like connectivity issues. There's a full list on the slide here, including things like when to check sign-in credentials, permissions, how to think about token failures, what an AJAX 410 kernel shutdown actually means, typically just a connectivity issue, and a few things around different capacity pausing components. Make sure you identify the different types of errors that are there and try and remember some of the common ones that you see. Many notebook errors actually end up tracing back to the Spark session itself, so you can always check the Apache Spark application UI you're using in the monitoring hub to see exactly what's going on there, and that might give you some better details in the form of the executor logs. Event House has a slightly different structure for its alerts because it's real time. So there's a lot of different possible states and meanings that we can encounter. Think of these as common things with common remediations. If it's running, it's good. We're fine. Maintenance means it's temporarily unavailable, but it means there's some sort of update or system change occurring. If you persist, escalate to an admin. Missing capacity means something has hit its limit. We can either refresh later, or we need to go and check details around how this is potentially working. Next, suspended capacity. We've hit a limit and our admin has actually put a policy in place. We need to contact our capacity admin to understand if it's possible to either increase or resume that capacity. An unknown? Well, this is exactly as it sounds. The best way is to escalate and start trying to identify heavy users to optimize their workload. It may be as simple as a resource allocation, over-consuming it, and preventing others from accessing it there. You can always use the central hub of the Event House page to look at all of these different monitoring tasks and try and understand the common problems. Essentially, it's a main view to give you real-time status of exactly how things are being put together. Pay attention to the details. Region, last ingestion, essential URIs for queries and ingestion. Different workspace monitoring components here really do matter. Just remember that missing capacity and suspended capacity, both are going to block access, but the cause differs. Really think about that meaning and think about if you're presented with a scenario, which one is the more likely one, because it'll change your remediation steps. Now, when we're working with event streams, there may be some potential errors we encounter there as well. The best place to be able to understand what's going on is the runtime logs. These give you detailed logs that occur in the event stream engine itself, and they have 3 different severity levels: warning, error, and information. Common metrics you should know: runtime errors are the total number of errors that occurred in the event processing. Data conversion errors, things that couldn't be converted to the expected output schema, basically something just didn't fit. Deserialization, so events came in and they just couldn't be put in the right order, in the right way. What the delay for watermarking your data was, Remember, if we want to have incrementals, we need to watermark. This tells you how long that's actually taking to do that action. And we can use all of these different components together to understand the performance and the current, running, if it's running okay, of an event hub, a lakehouse, or a streaming connector. If you need to focus on things like backlogs, runtime errors, this is where we go and get the deeper datas within those components. There's real-time visualization for simple checks, and for deeper troubleshooting, that's where that runtime logs tab exists with filtering, search warnings, errors, etc. When the event stream is producing a wrong or no output, just remember that that is always your first stop. Filter by severity, take a look and see if you can find that failing transformation. It'll allow you to drill through and work out exactly which entity is causing the problem and how the mismatch is happening. Now, when we're working with T-SQL, we do have a separate set of error categories to work with and a slightly different way to think about the way we're going to find the error's source. First, think about change feeds. We're going to use a different sort of check, and there's a few different categories we can look for there. We also have a whole bunch of things around connection issues that may occur if the object permissions are not working, different sorts of change data capture components that may happen related to different permission setups. Essentially, depending on what the issue is, we're going to need to query a different piece of the SQL DB we're connected to. Remember that within query execution itself, outside of mirroring, we're mostly going to be focused on resource allocation. TempDB being full, DMS operations failing because we've run out of capacity. We've got truncation errors because the data is mismatching or something along those lines. Try and identify these different components because they'll lead you easily to different bottlenecks, potential problems that are occurring, and different pieces within the change feed that allow you to identify if we just need more capacity or a fix-up of permissions along the way. Now, shortcuts, remember, these are just a symbolic link. So if we see an error, this allows us to easily identify if something has changed on the other side of the fence. Path validation, if we try and resolve a path, it tells us if something's wrong. Also tells us if we've used a reserved character that shouldn't be there. Iceberg table issues are focused on folder placement, metadata folder access, and things not being in the right order. And caching and network issues are, as they sound, something's wrong with the network level, and we need to work out what's happening there. On the access and permission side, there's going to be things like cloud connection failures. So if we're connected to an external source, something goes wrong, we can identify that that's the problem there. We also have the ability to identify things like security failures, so if there's insufficient permissions. Each of these present different potential scenarios for us to start following. Don't overlook things like cache and network challenges with latency as part of this, because they're quite common, especially in initial setups when we're still understanding how this connection is going to function. Since shortcuts are spanning two different trust boundaries, the one lake side and the external data store, just keep in mind that an error on your side might actually need to be rectified on the source side instead. Think about what the error actually means. Think about how you diagnose it and where you'd easily identify if the problem's not on your end. Now, once we're past debugging, we can think optimization. There are 6 primary optimization areas: lakehouse tables, pipelines, data warehouse, event streams and event houses, Spark performance, and query performance. Each of these have different types of commonly tested components to test how fast they are working. Optimize write is an example that we'll see. There's an optimize after that to be able to compact those files after the write. And these are complementary but not necessarily the same. We can use these in different scenarios to match what we need. Essentially, by using the different components here, we can understand how different functions are able to work across, say, a delta table within Spark. Pipelines need to focus on intelligent throughput and optimization, so try and reduce the amount of data movement. Keep it simple and quick. That's the best option for you. For Spark, think about caching. Fabric has an auto-tuning system which automatically adjusts configurations based on observed query behavior, so try and match those different pieces to the bottlenecks you're seeing. This is a root cause thinking problem. If you are seeing a problem that is coming through around performance, try and think, where would this be? Which particular piece of the source might this be coming from? Throughout this exam prep series, we have covered a lot of different objectives. And here we covered 3 primary ones. monitoring fabric items and the various ways in which we need to monitor them together, identifying and resolving errors related to your environment in various forms, and how to optimize your performance. And across all three objectives, we'd covered a lot of ground very fast. The goal of this was to take you through all of the highlights, implementing and managing analytics solutions in terms of those workspace settings, lifecycle management, security, and governance, ingesting and transforming data in the terms of batch ingestion, transformation, and streaming, and monitoring and optimizing, which we've just covered, focused on different ways to make this work. For more information, you can head on over to aka.ms/DP700 exam and review all the official areas around how DP100 works and the study guide therein. I want to thank you for joining us and good luck on the exam.